Okay, next topic, toroid. Toroid is a hollow circular ring on which a large number of turns of a wire are closely wounded. And magnetic induction for a toroid is B equal to mu naught N I by 2 pi R. Here capital N is the total number of turns and R is the radius or average radius. Suppose if it is not a uniform circular ring, then average radius will be taken. Next topic, force on a current carrying conductor placed in a magnetic field. That is, this is a conductor, L length of the conductor, which is placed in a magnetic field. As per this diagram, magnetic field is set up in Z axis. Magnetic field is set up in Z axis. And force on a straight conductor of length L and carrying a current I placed in a uniform external magnetic field B, that is F equal to IL cross B. F equal to IL cross B. And here IL is the current element or current vector and B is the magnetic field, F is the force. And we know the already formula, A cross B equal to, what is the formula? Cross product. A cross B equal to AB sin theta. Same way, IL cross B is IL B sin theta or B IL sin theta. And here theta is the angle between the current element I and magnetic direction of the magnetic field B. Okay. This point noted, no? Next, right hand rule. That is, curl fingers as if rotating vector I into vector B, then the thumb is then in the direction of the force. That is F equal to IL cross B. That is, it gives the direction of force with respect to the magnetic field. Okay, see here, thumb represents the direction of force on the wire. And curling the finger, no, this finger folded one, that gives the vector I into vector B. Okay. So this is gives the right hand rule, gives the direction of force on a straight wire of length. Next topic, force between current carrying wires. Two current carrying conductors placed near each other experience magnetic force. See here, two conductors, parallel two conductors carrying current, here IA, IB or I1, I2. Okay, as per the formula we are using I1, I2. Then two conductor carrying current placed near each other, it experience some force. That force may be attractive force or repulsive force. And what is the formula? F equal to mu naught into I1, I2 divided by 2 pi d. Mu naught as usual, permeability of free space or vacuum. I1 and I2 are the magnitude of current flows in first current carrying wire and second wire. And L, what is L? L is the length of the conductor, one conductor. D is the distance of separation or distance between two conductors. Then force on one conductor of length L due to current in other wire at separation D and parallel current attracts. That only yesterday we said parallel current means I1, I2 act in the same direction, then that is called parallel current. If it is parallel, I1, I2 act in same direction, then there will be an attractive force. Anti-parallel current, that is I1 acting in this direction and I2 acting in opposite direction, then that is a repulsive. I1 acting in this direction and I2 acting in opposite direction, that is repulsive one. Next, Next topic, Lorentz force. What is Lorentz force? Lorentz is a force experienced by a charged particle in a magnetic and electric field. That is called Lorentz force. What is Lorentz force? Lorentz force is a mechanical force experienced by a charged particle moving in a electric and magnetic field. And remember, this Lorentz force is applicable only for charges when it is in motion. At rest means there will be no experience of force. Okay, that is Lorentz force. What is Lorentz force? Lorentz force is a mechanical force experienced by a moving charge through electric and magnetic field. Formula is F equal to Q into E plus V cross B. F equal to Q into E plus V cross B. Here all are vector quantity except Q. Q is a scalar quantity and Q is a charge, and actually is nothing but, this force is nothing but force due to electric field and force due to magnetic field. Force due to electric field only Q into E, and force due to magnetic field is V cross B. V cross B. Then magnetic force depends on magnitude of charge, its nature and its velocity. When charge is at rest, it does not experience any magnetic force. That is, when charge is at rest, V equal to 0, so no force. And when charge is moving parallel to magnetic field, when charge is moving parallel to magnetic field means then theta equal to 0. Here V cross B is VB sin theta, and if theta equal to 0, sin 0 is, what is the value of sin 0? 0. So no force. That is why its value will be 0. Okay, so this force is not applicable for two factors. One is for charges at rest. Another one when the charge is moving parallel to magnetic field. For these two, it will not experience any force. Next topic, that is direction of magnetic Lorentz force. That is, B is a magnetic induction or magnetic field set up in Z axis as per the diagram, and V is the velocity of the charged particle which makes certain angle, theta angle, with respect to magnetic field. Then if the charged particle is positive charged particle, that is plus Q, then force will be experienced in which direction? Positive x-axis or negative x-axis, this one? Positive, yes. Positive x-axis. If it is plus Q, then force experiences outward as positive x-axis. And same, if it is negative charge particle, then force will be acting inward or negative, or this is positive x-axis and this is negative x-axis. Okay. So for positive charge, force will be acting in positive x, and for negative charge, force will be acting in negative of x-axis. Next, motion in uniform magnetic field. In uniform magnetic field, charged particle can have three types of path. This you can note down because in this way also some questions may asked. If it is straight line, if the charged particle traveling in straight line, when it will happen means when B is parallel to V. That is, when magnetic field, direction of magnetic field and the velocity of a charged particle are parallel, then it is straight line. And when V is perpendicular to B, it is circular path. When V is perpendicular to B, then charged particle moving in a circular path. Then during this perpendicular only, it acts as a centripetal force. Therefore, centripetal force F equal to mv square by r equal to bqv, and there v square and v getting cancelled. Then radius of circle r equal to mv by bq, and t equal to 2 pi by omega, omega equal to v by r. By substituting this, we will get t equal to 2 pi m by bq. This is a time period and this is a radius of the circular path. This only we are applying in cyclotron. And helical path. Helical path or spiral path when means when the velocity v and b are inclined at an angle other than 0, 90 and 180. Apart from 0 to 90 or 180. Then it will follow helical path or spiral path. Okay. Noted, no? Velocity selector. When electric and magnetic fields are crossed and velocity of particle is perpendicular to both field, then particles with speed v equal to e by b pass undeflected. That is, this principle is employed in mass spectrometer, Bainbridge mass spectrometer. And from this we can select the particular velocity. That is a particular, for example, electron means electron should travel this velocity. Increase the velocity, decreasing the velocity can be controlled using this formula. That is why we call this as a velocity selector. 330. And motion of charged particle in a uniform magnetic field. This only already we discussed, that is when it is moving in a circular path. And when the particle, charged particle moving in circular path, when it will move in circular path? What's the direction of B and V? Perpendicular or parallel? Check it. Perpendicular. Is it so? So perpendicular or parallel for circular path? Perpendicular. That is, velocity of the charged particle and the magnetic field are perpendicular, then it follows a circular path. Then when it follows a circular path, centripetal force will be provided. Centripetal force means F equal to mv square by r, and that force is equal to force due to magnetic field BQV, and by equating this we will get r equal to mv by bq. And omega, what is omega? Omega is the angular frequency. Angular frequency omega equal to v by r, and by substituting this r value there, vv getting cancelled, omega equal to bq by m. These two things we are applying in cyclotron. And time period t equal to 2 pi by omega. Time period t equal to 2 pi by omega, omega equal to bq by m, then t equal to 2 pi m by bq. Time period. Same way frequency also we can say. Frequency is the reciprocal of time period, therefore nu equal to means bq by 2 pi m. Okay. Frequency equal to bq by 2 pi m. And these things only we are applying in cyclotron. What is cyclotron? Cyclotron is a device used to accelerate charged particle to high energies. It was devised by Lorentz. That is why it's also called as Lorentz cyclotron. And as we discussed already, and as per that only mv square by r equal to bqv, on simplifying, v by r equal to bq by m is constant. That is, for a given magnetic field, B constant, Q charge of the particle constant, mass of the particle also constant, then bq by m equal to v by r. What is v? V is the speed of the particle and r is the radius of the circular path. These two also maintain constant, and therefore t equal to 2 pi m by bq also constant. And as we discussed, frequency is a reciprocal of time period, nu equal to 1 by t equal to bq by 2 pi m, bq by 2 pi m. Next, magnetic moment of a planar loop. Magnetic moment, mostly capital M will be used, a small m, no problem. Magnetic moment, small m, of a planar loop carrying a current I, having n closely wound turns, and an area A is given by m equal to n into I into A. M equal to n into I into A. This is a magnetic moment. And torque on current loop. Torque on magnetic dipole. What is torque? Turning effect of a force. That is called torque. Or moment of force. That is torque. Torque on magnetic dipole, that is a tau equal to mb sin theta. Tau is a torque, m is the magnetic moment, b is a magnetic field into sin theta. Then tau equal to m equal to nia. If you substitute this, then tau equal to nia b sin theta. Just you include b also. into B is there. B is missing into B. NIAB sin theta. Then any planar current loop is equivalent to magnetic dipole of dipole moment, that is M equal to I into A. Okay, this is a torque on a current loop. And this only we are going to apply in moving coil galvanometer. I think you noted? Noted, okay. Loop placed in a uniform magnetic field. When this loop is placed in a uniform magnetic field B, then the force F on it is F equal to 0. And the torque on it is tau equal to M cross B. In a moving coil galvanometer, this torque is balanced by a counter torque due to a spring yielding K phi equal to Ni into AB. Here phi is equilibrium deflection and K is a torsion constant of the spring. Here phi is the equilibrium deflection, phi or theta will be used, and K is the torsion constant of the spring. Moving coil galvanometer. Already we discussed in previous one session what is galvanometer, ammeter, voltmeter and all. Galvanometer is a device used to measure current, and this is a moving coil galvanometer used to measure current. And here at equilibrium position, two couple, deflecting couple equal to restoring couple. Deflecting couple, by passing current, that needle will deflect and it will oscillate, come to rest. That is a deflecting couple. Restoring couple, due to the suspension of the wire or elasticity of the wire, that wire tries to come back to, that pointer tries to come back to original position. So deflection will take place and comes to rest. That is the equilibrium. When the needle will come to equilibrium, when the deflecting couple equal to restoring couple. And deflecting a couple equal to formula NBIA equal to C theta. C theta is the restoring couple. Note down, C is a constant called couple per unit twist. C is a constant called couple per unit twisting. And I equal to, simplify for I equal to C by NBA into theta. I equal to C divided by NBA into theta, and C by NBA is constant for a given current. Therefore, this will be replaced by K. And K equal to C by NBA, that is called galvanometer constant. If you substitute, I equal to K into theta. And if you remove K, what will happen? I is proportional to theta. Okay. So I equal to K into theta, or I is directly proportional to theta. Okay. So if more current is flows in a coil, then deflection will be more, theta will be more. That is the meaning. Okay. Next topic, current sensitivity of a galvanometer. In a galvanometer, I equal to C by NBA into theta. And what is current sensitivity means? Deflection per unit current. Theta is the deflection angle, deflection per unit current. That is called current sensitivity. So I equal to C by NBA into theta we derived. Then theta by I equal to NBA by C. Theta by I equal to NBA by C, and here current sensitivity of a galvanometer can be increased by increasing the number of turns of the coil. That is how theta by I can be increased, by increasing the number of turns N. Theta by I is proportional to N. Another one, theta by I is proportional to B, that is by increasing the magnetic induction. And theta by I is proportional to A, so by increasing the area of the coil. And theta by I is inversely proportional to C. What is C? C is the couple per unit twist. So by decreasing the couple per unit twist, we can increase current sensitivity. That's why that suspension wire, suspension coil, that pointer suspension coil, that will be made up of one kind of alloy called phosphor bronze. It should be made up of phosphor bronze wire. Reason means phosphor bronze only produces small couple per unit twist. For a given twist, given rotation of twist, it gives small value of couple. That is why phosphor bronze will be used. Next topic, voltage sensitivity of a galvanometer. It is defined as the deflection per unit voltage. Current sensitivity, it is a deflection per unit current. This is deflection per unit voltage. Voltage sensitivity equal to theta by V equal to theta by Ig equal to N.B.A by Cg. Here N is the number of turns and B is the magnetic field, A is the area, C couple per unit twist, and G is the galvanometer constant. And here increasing current sensitivity does not necessarily increase the voltage sensitivity. Current sensitivity and voltage sensitivity different. When number of turns N is doubled, current sensitivity also doubled. But increasing the number of turns correspondingly increases the resistance G only. Hence, voltage sensitivity remains unchanged. Next topic, how can we convert galvanometer into an ammeter? That is a galvanometer only converted to ammeter as well as voltmeter. When it will be possible means when a galvanometer is connected with low resistance parallel. S is a low resistance. G is a galvanometer, and when it is connected with low resistance parallel, then galvanometer will be converted to ammeter. This dotted line, dotted square gives the complete circuit for galvanometer. Then Vg equal to Vs. What is Vg? Voltage across galvanometer or potential across galvanometer equal to potential across shunt. Here S is called shunt. What is shunt means? When low resistance connected parallel, that is called shunt. Vg equal to Vs. We know from Ohm's law, V equal to I into R. And Vg equal to current is Ig into its resistance is G. Ig into G. And Vs equal to, I is the current flows in a circuit, then Ig current flows through galvanometer, then remaining current, I minus Ig only goes to shunt. Okay. I minus Ig only goes through shunt. Then I minus Ig into S is Vs. From this S equal to, S is a shunt, S equal to G into Ig by I minus Ig. What is Ig? Ig is a current flows through galvanometer. I is the total current. S is the shunt resistance. G is the galvanometer resistance. And the shunt resistance is very small because Ig is only a fraction of I. The effective resistance of the ammeter RA is 1 by RA equal to 1 by G plus 1 by S. That is how is it? Two resistances are connected, series or parallel. G is a galvanometer resistance, S is the shunt resistance. These two are connected, series or parallel? Seriously you want to say? Series or parallel? Parallel. Parallel. Series is, this is only series. Okay. Right. So parallel. So for parallel we already studied that 1 by R equal to 1 by R effective equal to 1 by R1 plus 1 by R2. And RA is the resistance of the ammeter, 1 by RA equal to 1 by G plus 1 by S, or RA equal to G into S by G plus S. And RA is very low, and this explains why an ammeter should be connected in series. When connected in series, ammeter does not appreciably change the resistance and current in the circuit. Therefore, ideal ammeter is a one which has zero resistance. Ideal ammeter means zero resistance. Okay. So next topic is conversion of galvanometer into voltmeter. As we have discussed, galvanometer converted to ammeter when the low resistance connected parallel. Here reverse. When high resistance connected in series like this. G is the galvanometer resistance and R is the high resistance connected series. Then galvanometer is converted to voltmeter. Then Ig equal to V by R plus G. As we know the formula from Ohm's law, I equal to V by R. Here effective resistance is R plus G. So Ig equal to V by R plus G. Then what is the value of R equal to V by Ig minus G. And effective resistance of the voltmeter, as these two are connected series, effective resistance is R voltmeter equal to G plus R. And RV is very large, and hence a voltmeter is connected in parallel in a circuit as it draws the least current from the circuit. Okay, noted no? Can we move to next topic? Here RV is very large, and hence voltmeter is connected in parallel in a circuit as it draws least current from the circuit. And magnetic moment in an electron. An electron moving around the central nucleus has magnetic moment mu L. We will use capital M or small m, and in higher physics we will use mu. Mu is the magnetic moment symbol, and mu L given by mu L equal to E by 2m into L. And here L is the magnitude of the angular momentum of the circulating electron about the central nucleus. Okay. Here mu L is the magnetic moment equal to E by 2m into L. What is L? L is the magnitude of the angular momentum of the circulating electron about the central nucleus. Bohr magneton, this will be a last topic. Actually, what is Bohr magneton means? It is a unit of magnetic moment in atomic scale. That is, magnetic moment of the nucleus, magnetic moment of the electron, magnetic moment of the proton, that can be calculated in Bohr magneton only. And one Bohr magneton equal to 9.27 into 10 power minus 24 joules per Tesla, or ampere into meter square. Two units are there. Mostly ampere into meter square only is a unit mostly used one, or ampere into meter square. Okay. Okay. So that's all about today's topic, today's chapter completed. Thank you, students. And next session we will start next chapter. Next chapter will be chapter 5, magnetism and matter. So in next session we will start this chapter 5, magnetism.